Hello everyone, I'm Luis and I am a tutor at Strategic Test Prep. Today we're going to work on the question number 9 on the page 244, so I hope that you're ready for some geometry. Here we go. So in the figure shown, AB is equal to 185, so we're going to put that measurements. Then the segments AC is equal 4, and the segments CE is equal 10 units. The question is, what is the area in square units of the triangle ADE? So as you can see, I have two triangles, one that I'm going to call the larger triangle, and this one that is the smaller triangle. I don't have enough information to complete with my formula, A equals 1/2 times the base times the height, because of the largest triangle that I have, only the base is known. I need to find this part, right? But I don't have enough information, so I'm going to work with the smaller triangle, progressively finds the information that I'm missing. The first thing that I want is to find these segments. On the triangle ABC, what I can use is the Pythagorean theorem. Remember that when we have two sides of a triangle, you can find the third one using this theorem. This is the hypotenuse. So that means that x squared plus 4 squared is equal to the square root of 185 squared. Almost forgot. Now, clearly this cancels out, and then I have x squared plus 16 equals 185. I subtract 16 from both sides. X squared is equal to the difference, which is 169, which means that x is equal to the square roots. I'm going to put the square root on both sides. So I have that x is equal 13. Perfect. So I have the base and I have the height of this small triangle. I want to show you a trick. I can find the area of the small triangle. I'm going to call this area of ABC. This is 1/2 times base, which is 4, times its height, that is 13. So maybe I can simplify 4 with 2. The area is 26. What I want now is the scale factor. And I can do that because these triangles are proportional. If you notice, one is inside of the other, but more importantly, they share the same angles. They are both 90 degrees. They are both containing the angle A, and these two angles are going to be the same because these two lines are parallel lines. So if I find the scale factor, I can use this shortcut. What I want is two segments that correspond to each other that are completely known. For example, the base of the triangles. The base of the larger triangle is 4 plus 10, 14. I'm going to call the scale factor K, and I'm going to divide AE, which is the base of the larger triangle, over 4, which is the base of the smaller triangle, AC, which is going to give me 14. Remember to add these two over 4. Maybe I can simplify this to 7/2. Some of you are going to prefer decimal numbers, 3.5. The key is to remember, for the lengths, the scale factor is K. But for areas, the scale factor is K squared. Also for volumes, the scale factor will be K cubed because we use units, units squared, and cubic units, as you can imagine. The one that I'm interested in is areas. So if the area of ABC is equal to 26, the area of the larger triangle ADE will be 26 times the scale factor squared, which I already found. So the only thing that I have to do now is to plug that in, 3.5 squared, and I can use my calculator for that, or Desmos actually is wonderful. So our answer anyways is 318.5 units squared, and I hope that you like this video.